Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2 and we want to present our project about gas alert system. Before we talk about our project, let us introduce ourselves. My name is Ardi and Sejati.
And my name is Gloria Yoland Septryana.
So next, Gloria will talk about the table of content.
So our project title is named Gas Alert System. And now we're going to talk about the table of contents of our project first. So we have a total of 6 table of contents. The first one is system analysis, a short explanation about our project, and the second one is components, which will be talking about components and tools that we use in this project. And then the third one is schematic system, which is the photo of the system and how the systems work. And the fourth one is flowchart, all the flowchart that is needed for this project. And there are 3 kind of flowchart in this project, which is flowchart of the system, flowchart of Android app, and flowchart of the web applications. And next is the database design of our project. That will be talking about the database that we use for this project. And then the last one is system reading result. That will be talking about the output of our system. So now my friend Ardi will be explaining about the first contents, which is system analysis.
System analysis. So, Internet of Things or IoT is a computation concept of daily object that is connected to the internet and can identify other devices. Rather than make a smart home system, which is more expensive, in this project, we will make an IoT-based home appliance system. So, we decided to make a continuing project from our last project in third semesters, which is Smart Fan to Gas Alert System. So, the idea is from the Smart Fan, which is trigger the DC fan of the temperature to turn to trigger the DC fan of the gas alert system. So which means that if there is any gas, the DC fan will turn on and the buzzer too.
Next, I'm going to share about the components and tools that we use for this project. So we have a total of 10 components that we use for this project. The first one here is Node MCU, that is a microcontroller, which is added with the ESP8266 with Wi-Fi module. And then the second one is Arduino Uno. It's the same as Node MCU, which is a microcontroller, which will be connected to sensors and actuator or relay. And the next is DC fan. That will be the actuator, the output of this project. And the next is the relay, which is the actuator for this project, and to give signal current to DC fan. And then the fifth one is DHT11, which is the sensor that we use to detect the room temperature and also room humidity. And then next we have MQ2 sensor, which is a sensor to detect combustible smoke or gas in the current room. And then next is buzzer to give audio signal if the sensor value exceeds the determined limit that we set in Arduino. And then next we have breadboard as an electricity conductor to attach jumper cable so that the electric current from one component to another can be distributed with each other in breadboard. And then next is LED. In this project, we use LED to give us a signal if the data is sent. And then last, we have battery, or we can use any adapter that will be used to turn on the DC fan. So next is schematic system of our project. So this is our schematic diagram that we use for this project. Like I've said before in component and tools that we use Node MCU and we use Arduino Uno and we use some sensors. The sensors we use MQ2 to detect combustible gas and smoke, and we use DHT11 to detect the room temperature and humidity, and DC fan and buzzer and LED and relay, and also battery to turn on the DC fan if the sensor value exceeds the determined limit that we set. So this is the real photo of the system of our hardware. There's Arduino Uno, .mcu, MQ2 sensors, DHT11 sensors, buzzer, and also LED, also DC fan, battery, and relay. Next is flowchart, and my friend Ardi will explain the flowchart.
This is the flowchart system. So this is the flowchart system for the DMC. So the first is the parameter and the sensor, gas and smoke sensor will read the value from our room or our around the sensor. After that, after read the temperature and value smoke, it will transmit data to the node MCU ASP8266. After that, if the sensor value is more than 600, it will trigger the DC fan and buzzer to turn on. After that, this is where the flowchart go to the system of database. So the first is we get data from the node MCU and or the ASP8266. After that, we send the data to the SQL server and SQL database and Firebase real-time database. After that, save the data in the SQL and after that, display the data in the web application for the SQL and display data application display data in Android application. Okay, and this is the flowchart application. This is the flowchart application for the Android and web. So basically, for the Android, get the sensor value the Firebase real-time database. After that, it will display the sensor value in Android application. In the web, is get the sensor value from the SQL database. After that, display the sensor value in web application.
Next, I'm going to share about the database design that we use for this project. So before we show you the database that we use, first we want to tell you that we use two kind of database. So the first one database that we use is Firebase database, and then the second one is SQL database. So for Firebase database, we use it for our Android applications. And we can see it here. We have a gas, and we also have temp, which is the temperature from the sensor value DHT11, and it will be showing it as the real-time database. And we also have a small folder here, which called sensor, that we use it when we practice it out our system hardware. So the next one is SQL database. So we use SQL database for our website applications, and we have a table called TB_sensor, which includes the ID for the sensor value, and then suhu, which is the temperature that we get from the DHT11 temperature sensor, and then the third one is gas value that we get from MQT sensor, and then the last one is tanggal or date that we use to show the real-time date that we get from the sensor. And this is the data type that we use. For the ID we use integer, suhu or temperature we use integer, gas we also use integer, and for tanggal or date we use timestamp. So it will tell us the real time the data get into the database. So now let's see it. So the first one, this is our database in Firebase. Like I've said before, we have a gas and temperature, and we also have small folder here that we use for practice it out. So for the Firebase, we only can see the latest data that we got from our sensor. But for SQL, we can see it from the first time that we try it. We can see it here, the database that I use is graphic sensor, and the table is called TB sensor. So this is what it looks like. So I first tried in 17 July 2021. So from the first data to Sorry, let me change the number of rows first so we can see it more. So from the first data to this data is actually just an example data that we use to try the real-time SQL for the website. And this one, the suhu or the temperature is 0 because I have some problem when I practice out my microcontroller or our system hardware. So I have a problem with my sensor. And then we can see it here the next time that I try it. We have a value here. So this is where I started to get my sensor right. So this is what it looks like, and it will show the real time of the date that I tried out and also the time that I got the sensor. And we can see it here, the latest data that we got from our project. So this is the latest data that I got when I practiced it out my system hardware. So we can see it here, sometimes it's 300 or 800, something like that, because we practice it out and we try it out. So now I'm going to explain you about the system reading result that we got from our project. So the first one is Android applications that will be explained by my friend Ardi.
This is the Android application. So the Android application is only have the gas value, which is 274 ppm at that moment, and the temperature value is 31 degrees.
And then I'm going to explain about web applications that we make for this project. So we can see it here. We can upload. Okay, we can see it there. It's done uploading and we can see it from our serial monitor. So we can see it there. The first one is, wait, let me turn off the auto scroll. So we can see it there. The first value is for the temperature is 32 degrees Celsius, and for the gas value is 678, and it goes up to 679. See it there, and we can go to the web application. So let me go. Let me close it and let me open it again. So we can see it there because I played before. A minute ago, I placed the fire near the DHT11 sensor. So the suhu goes up from 32, the first value, to 33 degrees Celsius. And we can see it, we can also see it, the gas value goes up. It's going up from 6, wait a minute, let me scroll it again. From 678 to 680 gas value. So now let me try it again. So we can check it in our SQL database if it is real time or not. Let me refresh it first. So we can see the second page. So we can see it here. The latest data is 21st of July and 7 p.m. It's really the exact time. So you can see it here, the change of temperature from 33 to 35 to 32, because I place the fire near and far away from the sensor. And we can also see it here. The gas value is moving up and down because like I've said before, I place it far and near from the sensor. It seems like there are some problem with the data. So we can see it here. The gas is going up and down and the temperature too. We can see it the real-time graphic here. Like we can see it there. It's always moving up and down for the graphic. So that's all that I can show you for the website.
So, in this video, we test our gas sensor. If the gas sensor at 6 ppm, we'll turn on the buzz, the buzzer, and relay.
Dan ini tuh yang gede nanti kita percepat dead matiin.
So this is our circuit look like. So because we set it the gas value at 600, so if it exit at 600 gas value, it will turn on the DC fan. So we can see that we start at 660 60s, and now we're going to place it the gas near the MQ2 sensor. So now we can see it there, we started at 660s and now we are on 670s because we place it near to the gas. So we can see that there is a notification saying smoke detected because we set it at 600. So if the sensor value exceeds the 600 gas value, so I will be saying the smoke detected and I will turn on the fan like this.
So, thank you very much for the opportunity for us to explain our integrated system project. Assalamualaikum warahmatullahi wabarakatuh.